On this video, I'd like to deal with the concept of a linearized array. What that is the best way to describe it is by example. So if we have an array, let's call this array A. We'll use our standard example here, 99, 77, 1, 3, 42. Now, we've discussed already, it's basically linearized array is another way to index an array because it's sort of what's really going on inside of MATLAB's head. So MATLAB's using two different numbering systems to keep track. There's the numbering system that we've talked about thus far. So if I wanted to get to this value 99, that is rows and columns. So this is rows 1, 2, and 3, and columns 1, 2, and 3. And so the number 99 is in array A 2, 2. Likewise, and so that's the 99. Likewise, the number 77 is in row 2, column 3. So that's one way to get to values inside of an array. Another way, and I'm going to switch over here to a different color marker, is MATLAB also numbers the array locations with single digits, and so with one number. And so let me explain this. So it also says that this is spot 1, this is spot 2, this is spot 3, spot 4, 5, 6, 7, 8, and 9. And so it goes down the columns and then back up. So it has the numbering system of sort of this down, back up. Oh, excuse me, no, that's wrong. It goes down and then over to the next one, and down and over to the next one, and down. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so it's down the columns and then down each successive column. Well, what does that mean? Well, that means if I say, give me A at 5, it actually will give me the value 99. If I say, give me A at 8, it will give me the value 77. So this is another way that it indexes. So there are two different indexing schemes going on at the same time, which is okay. And so in black here is what we've come used to over the last few videos, but over here in red is the linearized way to do it. So with that concept, let's look through MATLAB here. So I define this array on line 5, and then on line 7 I say access A1. Well, A1 is going to be up here in the upper left, so that's 2. And then I'm going to proceed down the column. So I got 2, then 45 is A2, A3 is 1, and then I go back up to the top of the next column. And so I've got A4 would be the value 5, A5 would be the value 99 as we saw on the board, A6 is the value 3, A7 is the value 7 because I'm up here now. 1, 2, 3, 4, 5, 6, 7. So A7 happens to be the value 7 as well. 8 is 77. We saw that one on the board, and A9 is 42. So that's how the linearized indexing system works. Now, so now let's compare that. Let's go over here and compare that to let's compare the linearized indexing with the coordinate indexing that we've been doing thus far. Comment that back out. Let's scroll up here to the top. Okay, so what we're going to do here is I'm simply going to go through and look at the comparison between the linearized coordinated system on the left, and I have the equivalent sign, equal here, and the coordinate system on the right. And I'm going to show that they're the same because these values are all going to be true. So execute this again. Start off here. I once again define A, and then I come down here and say, does A1 equal A at 1, 1? That's true. A2 equals A at 2, 1. That's true. A3 equals A at 3, 1. That's true. So these are just two different coordinate systems going on here at the same time. The linearized one on the left and the coordinate system on the right. Well, I guess we call it the row column system on the right. A4 is equal to A12, A5 is equal to A22, A6 is equal to A32, 7 is A13, 8 is A23, and 9 is A33. Okay? Okay. Now, let's talk about that and where it shows up. It shows up in really two places. One I'm going to discuss right here, and the other one I'm going to discuss in the next video. Let's look at what happens when we do a find function on this array. Let's start over again with our array A. And let's look here at the find function. When I say find where A is greater than 60, well, where is A greater than 60? Well, A is greater than 60 at 99 and 77, right? These two locations here. Every place else it's less than 60. Okay, so if I do a find command on line 28, it returns the numbers 5 and 8. So find is going to return the linearized coordinates of where the value inside the find function, in this case A is greater than 60, where it's true. A is greater than 60 is true at linearized location 5. Remember, 1, 2, 3, 4, 5, and that's true because it's greater than 60. And also linearized location 8. This is 5, this is 6, 7, and 8. And so find, when you do it with an array, is going to return the linearized locations of where the value is true. Just like with an array, it returns the indexes, but since it's one-dimensional, those are linearized. We just didn't know it at the time. And then if I do a is greater than 60, and we'll see this when we talk about logical operations, but I just want to show it here now. Just a plain A is greater than 60. That actually gives me the whole array, and it's a logical array. If you look over here in the workspace, it's a logical 3x3 array. And the zeros are where that value is false, and the ones are where the value is true. And then see, once again, that's where 99 and 77 are. Okay? And we'll see more of that when we talk about logical operators. So once again, in summary, linearized arrays are just another indexing system other than the row column indexing system that we've been doing earlier.